Hello friends, so now we'll be explaining the generation of AM waves using square law modulator. We'll also be explaining the demodulation using the square law demodulator. Now, the generation of AM waves using square law AM modulator uses a square law function. The square law function can be defined as f of x is equals to ax square plus bx plus c, where a, b, c are constants and x is the signal. Now the circuit that will generate a square law AM wave is basically this. We have this carrier EC cos 2 pi FCT, the modulating signal, also called as message signal XT. The nonlinear device, this nonlinear device is basically a transistor or a diode or similar device. And we have this band pass oscillator. Mostly it's called band pass filter with frequencies with the same frequency centered at FC. The key components I've already told it. So now V1, this V1 voltage is the input to the nonlinear device, and it's basically a sum of the modulating signal and a carrier wave signal. V2 is the output of the nonlinear device. So V1 can be written as x of t plus EC cos 2 pi FCT. Now V2 follows the square law function with C equals to 0. So if we put C equals to 0, we'd be having AV1 square plus BV1, which has been written out here. On expansion we will be getting this V2. Now this can be rearranged into two forms, two terms. Basically this blue term is having the component with cos 2 pi FCT, while these red terms are other components. This red part is completely useless for us. We are for our modulation. This blue component is important. Now when we pass this V2 across a band pass filter centered at FC with passband gain G to be 1 by B, we get our output voltage V out as G times BEC cos 2 pi FCT plus 2AXT AC cos 2 pi FCT. As can be seen, the red parts have been terminated by this band pass filter. On further rearranging, we and using G as 1 by B as well as taking 2A by B as Ka, we get our required modulated signal V out as EC times 1 plus Ka xt times cos 2 pi FCT. This modulating signal is then sent to the channel and is received by a receiver. The already I have mentioned that we'll be using a filter, band pass filter centered at frequency FC. This band pass filter can be constructed as LC tuned circuit, which has tuning at FC with bandwidth FM, bandwidth 2 FM. The demodulating AM wave. This is just a signal that is modulating signal that will be receiving in the receiver. Here we can simply represent this signal as S of t is equals to EC times 1 plus KXT cos 2 pi FCT. From here we have to recover the message signal, also called X of t. This signal is then passed through the square law demodulator for extracting the message signal. This is a representative diagram of the square law demodulator. The V1 is basically a S of t. Now output of this square law device would be V2. This V2 is then passed through a low pass filter and we get V3. I have not shown it out here, but V3 is then passed through a capacitor, coupling capacitor, so that we can erase the DC component. We'll speak about it later on. So now V1 is basically S of t. This square law device basically follows the previously defined square law function only. That is in previously we had already defined that f of x is equals to ax square plus bx plus c. This is the square law function. And here we again put c equals to 0. So basically V2 we get as bv1 plus av1 square. We replace v1 with s of t, and s of t is expanded again. This was s of t. On expansion we get this v2 is equals to bec plus 1 plus kxt times cos 2 pi fct plus a times ec times 1 plus kxt cos 2 pi fct. This whole term is squared. On rearranging multiple times, we'll get this. Now further simplification will lead to these two terms, basically these red terms and this non-red term. On passing, this red term is centered at frequency fc, these red terms are also centered at frequency 2fc, and these terms are centered at frequency fm. Now this kxt square is basically centered at frequency 2fm. So on passing through low pass filter centered at fm with bandwidth w, the red terms will vanish along with this term k a by 2 ac square kxt. Now so basically we are the v3t, basically the output from this low pass filter that we receive is g times a by 2 ec square plus e square kxt, where g is the gain of the low pass filter. So if we take g to be 1 by ae square ka, we get v3 of t equals to 1 by 2 ka plus xt. On passing this voltage through a coupling capacitor, we will get the required xt, because xt is an AC signal. On the other hand, this 1 by 2k is a DC component which will be eliminated by the coupling capacitor. This is all about modulating and demodulating waves using square law function. Thank you.